The idea of a flat Earth is not new. It dates back to ancient times when early civilizations tried to make sense of the world around them. They observed the horizon and the way ships disappeared from view, leading them to believe the Earth was flat. Ancient civilizations held this belief. Cultures such as the Mesopotamians, Egyptians, and Greeks all had their own interpretations of a flat Earth. These ideas were deeply rooted in their mythology and daily life, influencing their architecture, navigation, and even their religious practices. However, science has long proven the Earth is a sphere. The work of astronomers like Ptolemy and later Copernicus laid the groundwork for our modern understanding. The advent of space exploration provided undeniable evidence, with images of our planet from space showing its true spherical shape. Despite this, the flat Earth theory has seen a resurgence in recent years. This revival is puzzling to many, given the overwhelming scientific evidence. Yet flat Earth conventions and meetings are becoming more common, drawing in curious minds and dedicated believers alike. The internet and social media have given a platform to these ideas. Online communities and forums allow like-minded individuals to share their theories and evidence, often creating echo chambers that reinforce their beliefs. Algorithms on social media platforms can also contribute to the spread of these ideas by promoting content that aligns with users' existing views. Many people are drawn to the simplicity of the flat Earth model. It offers straightforward explanations for complex phenomena, which can be appealing in a world that often feels overwhelmingly complicated. The flat Earth model provides a sense of certainty and control, which can be comforting. It's important to remember that just because an idea is simple doesn't mean it's correct. Critical thinking and scientific inquiry are essential tools in discerning fact from fiction. While the flat Earth theory may offer simple answers, it fails to account for the vast body of evidence supporting the spherical nature of our planet. As we navigate the information age, it's crucial to approach such theories with a healthy dose of skepticism and a commitment to seeking the truth. One of the most compelling pieces of evidence for a round Earth is the existence of satellites. These sophisticated machines orbit our planet, providing us with communication, navigation, and weather forecasting. For satellites to function properly, they rely on the Earth's curvature. If the Earth were flat, satellites would not be able to maintain their orbits. Have you ever noticed how the horizon appears to curve as you look out at the ocean or a vast expanse of land? This curvature is another indication of Earth's spherical shape. As you stand on the Earth's surface, your line of sight extends outwards in a straight line. Because the Earth is curved, this line eventually intersects with the Earth's curvature, creating the illusion of a curved horizon. Gravity is a fundamental force of nature that pulls everything towards the center of mass. For a large object like the Earth, gravity pulls equally from all directions, resulting in a spherical shape. If the Earth were flat, gravity would pull everything towards the center of the flat plane. This would mean objects further away from the center would experience a weaker gravitational pull. Section 5. Flat Earth Arguments Debunked. Proponents of the flat Earth theory often cite various arguments to support their claims. However, these arguments have been repeatedly debunked by scientific evidence. For instance, flat earthers often claim that the absence of a visible curve in photographs proves the Earth is flat. However, this is simply due to the immense size of the Earth relative to the scale of human observation. Section 6. The Sun and Moon. More evidence for a round Earth. The celestial bodies that we observe in our sky, particularly the Sun and the Moon, provide compelling evidence that supports the notion of a round Earth. By examining their movements and the phenomena associated with them, we can gain a deeper understanding of our planet's shape. The way the Sun and Moon appear in the sky is another piece of evidence against a flat Earth. If the Earth were flat, we would not observe the consistent and predictable patterns of day and night. Instead, the sun would illuminate the entire surface at once, or not at all, depending on its position. However, what we actually see is a gradual transition from day to night, which can only be explained by a spherical Earth rotating on its axis. We observe day and night cycles because the Earth rotates on its axis, causing different parts of the planet to face the sun. This rotation results in the sun rising in the east and setting in the west, creating a 24-hour cycle of daylight and darkness. This phenomenon is consistent across the globe, further reinforcing the idea of a round Earth. Additionally, the varying lengths of day and night throughout the year due to the tilt of the Earth's axis provide further evidence of our planet's spherical nature. The phases of the moon, from new moon to full moon, are also explained by the moon's orbit around the Earth and the changing angles at which we view its illuminated surface. As the moon orbits our planet, the portion of its surface that is lit by the sun changes, creating the familiar cycle of phases. This cycle is predictable and consistent, and it aligns perfectly with the understanding of a round Earth. If the Earth were flat, the moon's phases would not follow the same pattern, and we would observe irregularities in its appearance. Furthermore, the phenomenon of lunar eclipses, where the Earth casts a shadow on the moon, also supports the idea of a spherical Earth. The shadow that we see during a lunar eclipse is always round, which would not be the case if the Earth were flat. These observations, combined with the evidence from the sun and moon, provide a comprehensive and compelling argument for the roundness of our planet. Section 7. Circumnavigating the globe, a journey around a sphere. For centuries, people have circumnavigated the globe, traveling around the Earth. This feat is only possible if the Earth is a sphere. On a flat Earth, circumnavigation would be impossible, as you would eventually reach an edge. Section 8. The power of conspiracy, why flat Earth beliefs persist. The persistence of the flat Earth theory, despite overwhelming evidence to the contrary, speaks to the power of conspiracy theories. Conspiracy theories often provide simple explanations for complex phenomena, making them appealing to some individuals. They can also foster a sense of community and belonging among believers. Section 9. Critical thinking, your best defense against misinformation. In the age of information overload, critical thinking skills are paramount. Critical thinking involves questioning information, evaluating evidence, and forming conclusions based on logic and reason. When encountering claims that seem outlandish or contradict established scientific knowledge, it's crucial to approach them with a healthy dose of skepticism. Section 10. The importance of scientific literacy in the modern age. Scientific literacy, the understanding of basic scientific concepts and the scientific method, is essential for navigating the modern world. It empowers individuals to make informed decisions about their health, the environment, and their understanding of the universe. By promoting scientific literacy, we can help combat the spread of misinformation and foster a society that values evidence-based reasoning. Section 11. Conclusion. The undeniable truth, our round Earth. The evidence for a round Earth is overwhelming and comes from multiple branches of science. This conclusion is not based on a single piece of evidence, but rather a multitude of observations and experiments conducted over centuries. Scientists from various fields, including astronomy, physics, and geology, have all contributed to our understanding of Earth's shape. From satellite imagery and the curvature of the horizon, we can see clear visual proof of Earth's roundness. These images, taken from space, show the planet as a beautiful blue sphere, with the curvature of the horizon providing a direct visual cue. The laws of gravity also support the round Earth theory. Gravity pulls objects towards the center of mass, which, for a planet, results in a spherical shape. This is why planets, including Earth, are round rather than any other shape. The ability to circumnavigate the globe further reinforces this fact. Explorers and travelers have been able to sail and fly around the world, returning to their starting points, which would be impossible if the Earth were flat. The spherical shape of our planet is an undeniable fact. The rotation of the Earth, as observed from space, shows a consistent and predictable pattern that aligns with a round object spinning on its axis. While it's important to approach alternative viewpoints with an open mind, we must also recognize the difference between skepticism and denial. Healthy skepticism involves questioning and seeking evidence, while denial ignores overwhelming proof. We must also be willing to accept scientific consensus when it's supported by a preponderance of evidence. The Earth is round, and this conclusion is backed by a vast amount of data and research. Scientists around the world agree on this fundamental truth. Understanding this fundamental truth is crucial for appreciating the wonders of our universe. By accepting the round Earth, we can better understand our place in the cosmos and the natural laws that govern it. This knowledge allows us to explore further, to dream bigger, and to appreciate the beauty and complexity of the universe we inhabit. Throughout history, many great minds have contributed to our understanding of Earth's shape. From the ancient Greeks who first proposed a spherical Earth to modern scientists using advanced technology, the journey to this knowledge has been long and fascinating. Education plays a vital role in spreading this knowledge. By teaching the next generation about the true shape of our planet, we ensure that this fundamental understanding continues to be passed down, fostering a society that values scientific inquiry and evidence-based conclusions. As we look up at the night sky, we are reminded of our place in the universe. The round Earth is just one of many celestial bodies, each with its own unique characteristics. By understanding our planet, we gain a deeper appreciation for the vastness and wonder of the cosmos. The exploration of space has further confirmed the round shape of Earth. Astronauts aboard the International Space Station and other missions have provided first-hand accounts and images of our planet, all showing a round Earth. This international collaboration in space exploration highlights the global consensus on this fundamental truth. In conclusion, the round Earth is a well-established fact supported by a wealth of evidence from various scientific disciplines. Embracing this truth allows us to continue making progress in science and technology, pushing the boundaries of human knowledge and exploration. Let us celebrate the undeniable truth of our round Earth and the incredible journey of discovery that has led us to this understanding.